is the molar mass of a gas if 57.0 grams of it occupies 36.7 liters of space at standard pressure? And by the way, what is it? This is a kind of question that you could use the ideal gas law to find. Notice it doesn't give beginning and end, it just gives you information and asks for other information. That is ideal. So the thing that it's asking you for is the molar mass. So the W, the molar mass formula, is that GRT over PV? I hope so. Excuse me. That sounds right to me. How about that? Let's go ahead and let's do it. Let's do this thing. So hopefully it's going to give me all of those pieces of information and I can do this. What is G? Well, G is given as 57.0 grams. There we go. R. Okay, anytime you plug in R, you got to look ahead. Got to look ahead and see what's the pressure they're going to give us. This just says standard, so we can use whatever we want. When I can use whatever I want, I use the 0.0821 value because then I can plug in a 1 somewhere else. Liter atmosphere per mole. Kelvin. And T is oh, I can't do this problem. It didn't give me a T. Oh my goodness. Yeah, I wrote it down and I forgot to copy it onto the example problem. 25 degrees Celsius, should have said that, doesn't say that on there. Of course, you cannot plug 25 degrees Celsius in because we have to work in Kelvin, so I'm going to add 273 to that to get 298 Kelvin. Again, that 25 degrees, that was a oversight. An oversight, I should have had that on the problem. That would have been given in the problem itself. I just forgot to type it in. So 298 kelvins. Pressure. Pressure is standard, so I'm going to use 1.0 atmospheres. And the volume is the last thing we've got to plug in, and that is given. That is 36.7 liters. Now, what we're going to do next is we're going to make sure that all of the units cancel out properly so that we get the right answer. And also, some people have trouble. They never remember what the unit for molar mass is. So what we can do is we can just look and see whatever's remaining when we get done canceling all this stuff out. And that way we'll know. So grams is on top, and I do not see it on the bottom. So grams stays. Liter is on the top, and there it is again on the bottom. So goodbye. Atmosphere on top and bottom, goodbye. Kelvin on bottom and top, goodbye. Mole is on bottom but not on top. I believe all that's left is gram on top and mole on the bottom, which do not cancel. So we're going to leave that in terms of grams per mole. That's the unit answer. Now we've got to get the number answer. 57.0 times 0.0821 times 298 divided by 1.00 divided by 36.7, and I get 37.99865, which is going to round off to 38.0. So my molar mass is 38.0 grams per mole. And then I'm asked what kind of gas it is. Well, how in the world am I going to get that? Well, I'm going to look at a periodic table, and I'm going to look for things that are gases. And I'm going to look for things that are gases that have a molar mass of 38. So if I see the gases are the red ones on the periodic table, xenon's 130, that's too big. Krypton 83, too big. Argon's close, it's 39.9, that's 40. That's a little bit too big, so we can't choose that. Chlorine's 35.5, it's too small. Neon's about 20, that's too small. None of them fit. Oxygen's only 16, nitrogen's only 14, fluorine's only 19. So how are we going to do this? We just choose the closest one? No, we don't. It's got to be the right one. It's got to be exactly 38. How are we going to do that? Well, I think you all know how we're going to do that. Hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, chlorine. What do you remember about them? They are diatomics. What does that mean? That means their molar mass is always going to be 2 of those atoms together. So if you go back and look at your periodic table, any of those things that are gases, they're all, I guess iodine's not a gas, bromine's not a gas, so we can leave those off our list. We need to check hydrogen, oxygen, fluorine, nickel, nitrogen, and chlorine. We need to double each of those masses and see if any of those match 38, because they're Hofbrinkels. We got to double them. Hydrogen is 1, becomes 2. That doesn't work. Oxygen is 16, becomes 32. 38 was our number. That doesn't work. Fluorine is 19. 19? Oh, we have a winner! We have a winner. This is fluorine gas, isn't it? Yay! We figured it out. We're awesome.